Now we'll be discussing the relation between roots and zeros of a polynomial. Suppose we take a quadratic polynomial. The general form for a quadratic polynomial is ax square plus bx plus c. And let the roots of this polynomial be alpha and beta. Alpha and comma beta be the two roots. So there are two relations between the roots and the coefficient. The first one being alpha plus beta is equal to minus b by a, and the second relation is alpha into beta is equal to c by a. Similarly, if you are having a cubic polynomial, then the form would be ax cube plus bx square plus cx plus d, and let the three roots of this cubic polynomial be alpha, beta and gamma. Then the relation between the roots and the coefficients are as under. The first one would be alpha plus beta plus gamma is equal to minus b by a. The second relation is alpha beta plus beta gamma plus gamma alpha is equal to c by a, and the third relation is alpha into beta into gamma is equal to minus b by a. Now we'll understand it through an example. Suppose we take a polynomial x square minus 2x minus 8. Here a is 1, b is minus 2 and c is equal to minus 8. So if you find out minus b by a, it will come as minus of minus 2 will be 2 by a, and if you calculate c by a, it will be minus 8 by 1, which is equal to minus 8. Now let us find the two roots. For x square minus 2x minus 8, if you go by factorization, you will be having x square minus 4x plus 2x minus 8. I have used middle term factorization over here. So it would be x minus 4. Then we take 2 common, it would be another x minus 4. So we are getting x plus 2. The second one is x minus 4. If you equate it to 0, we equate this to 0, then you will be getting the two roots as x is equal to minus 2 and x is equal to 4. So suppose alpha is equal to minus 2 and let beta is equal to 4. So what is alpha plus beta? Alpha plus beta is minus 2 plus 4, it will come as 2. And what would be alpha into beta? This would be 4 into minus 2, this is minus 8. Now you see for yourself, minus b by a is 2 and alpha plus beta is 2. Both the values are equal. So if I mark this as 1, this is 2, this is 3, this is 4. So from 1 and 3, what do you get? From 1 and 3, we are getting alpha plus beta is equal to minus b by a. And similarly, from the second and the fourth relation, you see that the product of the roots, alpha beta is same as c by a. So alpha into beta is equal to c by a. This relation or the result would held true for all the expression. If you have any polynomial in degree 2 and you are finding the roots, then the relation between the roots and the coefficient would be as under. Alpha plus beta would be minus b by a, and alpha into beta would be c by a. This result is always valid. Now suppose if you are given the sum of the roots, alpha plus beta we also sometimes call as s, wherein s is the sum of the roots, and if the two roots, if you are multiplying, the product is written as p. So if the sum of the root is s and the product of the root is p, then we are framing the polynomial as x square minus sx plus p. That is, it is nothing but x square minus alpha plus beta times x plus alpha beta. So this is a form wherein if you are aware of the sum of the roots and the product of the roots, then you can create or write the polynomial. X square minus sx plus p would be giving you the polynomial if the sum of the roots and the product of the roots is known to you. The next which we will be discussing over here is division algorithm. What is division algorithm? In division algorithm, what you have is, if px is a polynomial of degree greater than equal to 1 and gx is another polynomial which is a non-zero polynomial, if you are dividing px by gx, then the division goes like this. This is px, this is gx. You'll be getting some quotient, and after a series of steps, some remainder. Then division algorithm says px will be equal to gx into qx plus rx. That the dividend polynomial, px is the dividend polynomial here, gx is the divisor polynomial, qx is the quotient polynomial, and rx is the remainder polynomial. So the division algorithm says we are having a polynomial px which is divided by another polynomial gx. If you are dividing px by gx, the quotient is qx and the remainder is rx. Then we will be having the relation as under px equal to gx into qx plus rx. So suppose if you are having a polynomial x square plus x plus 1, and if you are dividing it by, suppose say x plus 1, then you multiply it by x, you will be getting it as x square plus x, then the remainder over here is 1. So you will see for yourself that x square plus x plus 1, this is px, then we are having gx is x plus 1, qx is x, and rx is equal to 1. So when you are multiplying gx with x, you will be getting x into x plus 1, which will give you x square plus x, and rx is 1 over here. So when you add 3, you will be getting over here, the left hand side is x square plus x plus 1, and the right hand side is x plus 1 into x plus 1. If you multiply, you are getting it as x square plus x plus 1. So the two values, they match. LHS and RHS, the two values are matching. So this result is said to be division algorithm. The use of division algorithm is, suppose if you are knowing a polynomial of degree n and you are aware of one of the factors, then what you can do is you can divide the polynomial by the factor given, and whatever be the quotient, you will be getting a quotient which would be of a lesser degree. Suppose we are having the dividend a polynomial of degree 4 and the divisor is a polynomial of degree 2. Then when you are dividing a polynomial of degree 4 by a polynomial of degree 2, then the quotient would be a polynomial of degree 2. So what you can do next is, already you are knowing the divisor, you know the quotient. With the help of the quotient, you can factorize and you can get the other two zeros. So all the zeros of the polynomial can be obtained. So division algorithm is helpful in getting the other zeros, provided you are knowing a factor of the polynomial. Thank you.